Welcome to our math class for today. And for today's lesson, we will be looking at some work examples under set. In our past lesson, we've been discussing sets. So let's look at this example that covers most of what we've been doing under set that has to do with the complements, symmetric difference, the Cartesian coordinate, or the Cartesian product, or the cross product of a set, and finding intersections of set, finding union of sets. So let's look at this example. The example says, if A, B, and C are sets of, okay, so let's erase one of this stuff. If A, B, and C are subsets of the universal set, U, which is equal to prime numbers less than 20, and set A equals all X, and remember now that this is in the set builder notation, all X such that 1 is less than or equal to X, and X is also less than or equal to 10. And B is all X such that X is greater than 5, and then C is all X such that X is less than 7. Okay. So we go about the questions that were given to us from this problem. The first question says we must find the elements of set U, set A, set B, and set C. So what are the elements of these sets? So let's look at U, set U first. Set U says prime numbers less than 20. So let's look on the number line. This is the number line, for example. We have from 1 all the way to 20, right? So we say let this be 0, this is 1, 2, 3, 19, 20. So we have from 1 all the way to 20. They said prime numbers less than 20. So when a number is a prime number and that number is less than 20, it means that number should be between 1 or from 1 all the way to 20. What are prime numbers? We said prime numbers are numbers that have exactly 2 factors. The number itself and 1, right? For example, 2 times 1 is equal to 2. These 2 numbers are the only 2 numbers we can multiply to give us 2. Therefore, 2 is a prime number. 3, 5, 7, and so forth. So let's identify the prime numbers here, right? So we told you that 1 is not a prime number. So let's move on. 2 is a prime number. 5 is a prime number. 3 is a prime number. 7, 11, 13, 17, and 19. So those are all of the prime numbers that are less than 20. So we have our universal set now to be 2, 3, 5, 7, 11, 13, 17, and 19. So these are all of those elements that are part of the universal set. So the next thing we asked to do is to find the set A. What are the elements of set A? What is set A first? If we look at set A up there, set A is all X such that 1 is less than or equal to X when the same X is less than or equal to 10. Now what does this mean? There's an inequality notation. If 1 is less than X, it means X is greater than 1. It's just like you say if Peter is less than 0 in age, it means Sarah is greater than Peter in age, right? So x is greater than 1. And then the same x is less than or equal to 10. Now, what does it mean? These x that we are referring to are all of those numbers that form part of the universal set. So 2, 3, 5, 7, 11, 13, 17, and 19 are all referred to as the x. So they are saying that x should be greater than 1, meaning x should be greater than 1. So x could be 2, x could be 3, x could be 5, x could be 7, x could be 11, 13, 17, or 19. But let's not dwell on the first inequality or the first notation there to tell us or the members of set A. Let's look at the second one. The first one says x is greater than or equal to 1. The second one says x should be less than 10. So when x is greater than 1, but it should be also less than 10. So let's look at now. 2, 3, 5, 7, they are all greater than 1. And then all of these numbers also, they are less than 10. So therefore, we say that the set A now is just equal to elements 2, 3, 5, and 7. So we look at set B. Set B says all x such that x is greater than 5. Now, so they are saying that x should be greater than 5. Mind you, you are not going to select just any other number. Your guardians for this whole thing is your universal set. If x should be greater than 5, it means you should select all those numbers that are greater than 5 from the universal set. So when they are greater than 5 now, it should be 7, 11, 13, 17, and 19. So those are the elements of set B. So B now becomes 7, 11, 13, 17, and 19. So these are all of the prime numbers that are within the universal set that are greater than 5. And then lastly, we have set C. Set C says all x such that x should be less than 7. So from the universal set, if we look at the universal set and we are selecting values, all those values must be less than 7. So all those values that are within the universal set, all these elements representing the x. So we are saying that x must be less than 7. So you have 2, you have 3, you have 5. So those are the 3 numbers that are less than 7 within the universal set. So we have set C now to be 2, 3, and 5 are the elements. So therefore, we have the universal set to be equal to 2, 3, 5, 7, 11, 13, 17, and 19. Also, we have set A to be 2, 3, 5, and 7. Set B now is all those elements that are greater than 5, 7, 11, 13, 17, and 19. And then set C now is 2, 3, 5, and all those elements are less than 7. So these are the elements of the universal set and the 3 other sets given. The next question says, we must find the complements of A, of B, and of C. So the second one said, the complements, must find the complements of A, B, and C. So move to the first one, A. The complement of A is denoted as A prime, or we say A raised to the power C, right? Okay, so let's use A prime. So A prime, to get the complement of a set, the formula is the universal set minus the set itself. So the universal set, this is the universal set, and then you subtract A from this universal set. So let's look at them. We have set A prime now to be, the universal set is 2, 3, 5, 7, 11, 13, 17, and 19. This is set A. So it will just cancel out all of these elements that are within set A from the universal set. The remainder has to do with the complements of A. Complements means those elements that are found within the universal set but are not found within A. So you have 11, you have 13, you have 17, and you have 19. So we also move to excuse me, the complements of B, which is U minus B. So B prime now will be, so we look at set B and the universal set. This is set B, and there's a universal set, right? So all of those elements that are within in set B, you are not going to include them in B prime. So let's look there. You got 7, you got 11, 11, 13, 13, 17, 17, 19, 19. So from here, from this point, all these elements, they are already part of set B. So the ones that are not part of set B now, but within the universal set, are what we call B prime, the complements of B. So we just have B prime to be 2, 3, and 5. And then also we have C prime. So C prime is the same thing, U, the universal set, minus set C. So we have C prime now to be equal to all of the elements within set C, subtract them from the universal set. So now you look there, 2, 3, and 5. 2, 3, and 5. Subtract them from there. The remaining elements are all the complements of C. So the remaining elements are 7, 11, 13, 17, and 19. So these are all of the complements of, set A, set B, and set C. So let's take note of them. Okay, so we'll move on to the next one. Question number 3 says, we must find A union B. Question 3 up there says A union B. That is A union B. So when we talk about union, we talk about combining two sets, right? Combining two or more sets. So if you are asked to find A union B, it means you must find the combination of A union B. Remember, one of the properties provides that we must not repeat the elements within a set. So A and B, we combine them. This is A, this is B. So A will have 2, 3, 5, 7. B will have 7, 11, 13, 17, and 19. So we list them 2, 3, 5, 7, 11, 13, 17, and 19. So 17 appeared twice. 17 is in A, 7 is in A, 7 is in B, but we did not write 7 twice because the 7 must not repeat those elements. So the next one, question 4, we have A prime intersect C prime. So it's A prime intersect C prime. Now we've already found our A prime to be this, and we found our C prime to be this. So between A prime and C prime, what are those elements that are within A prime that are also within C prime, right? So we look there, we have 11, we have 11. We have 13, we have 13. We have 17, we have 17. We have 19, we have 19. So all of the elements that are within both sets are referred to as the intersection. So we have 11, 13, 17, and 19. So 5. B intersect C. B intersect C. What is the intersection for B and C? B and C. What are those elements that are within B that are also within C? If you look at 7, 11, 13, 17, and 19, 2, 3, 5, there is no element that is in B that is also within C. So we call that an empty set. So there's just a symbol of empty set. Or you can also write this symbol like this. But you don't write all two, write one of them. 6. 6, we have A intersect B prime or prime. So it's just simple. So the first thing here we need to do is to find A intersect B prime. Then from there we'll find A intersect B or prime. So what is A intersect B? Look in set A and look in set B prime. What are those elements that are within set A that are also within set B prime? In set A we have 2. In set B prime we have 2. Set A we have 3, B prime we have 3. Set A we have 5, B prime we have 5. So the intersection for A intersect B prime is just 2, 3, and 5. Now we find A intersect B prime or prime. That is to say, this set that we just found, what are the complements to this set that we just found? Now compare this set with the universal set. So if we say the universal set minus A intersect B prime, all those elements that are within the universal set that are not within A intersect B prime, which is this set. So if we look there now, we will have 2, 3, and 5. 2, 3, and 5. So the rest of these elements are the complements. 7, 11, 13, 17, 19 are all the complements. Now also we have question number 7. And question 7 says A prime union B intersect C prime. So what is A prime union B? So we first find A prime union B. So we look at A, set A prime. Here is set A prime. And then set B. This is set B. So set A and set B, we must combine them together. This set A prime and set B, we must put them together. That's a union. So in set A prime, we have 11, 13, 17, and 19, right? And then in set B, we have 7, 11, 13, 17, and 19. So we just start from 7 and we reach 11, 13, 17, and 19. So there is A prime union B. So now we can find A prime union B intersect C prime. So this set that we have just found, let's observe within this set that we just found, and we look within C prime. This is C prime. What are those elements that are within C prime that are also within this set we just found? So you have 7, 11, 13, 17, and 19. Also here we have 7, 11, 13, 17, and 19. So the intersection is just 7, 11, 13, 17, and 19. Okay, so we move on. The next one says, I think we can put some stuff on this side. We still have space here. Next one says, question 8. Says we must find the number of B intersect C prime. This thing, the number, or we call it the cardinality. The cardinality has to do with the number of elements within a particular set. So let's first find B intersect C prime. What are those elements within B intersect C prime? What is set B? This is set B. What is set C prime? This is set C prime. So there is B and then C prime. So all those elements that are here, that are also here, they are the same, right? All of these elements. So you got 7, 11, 13, 17, and 19 are the intersection for B and C prime. Now we find the number of elements within B intersect C prime. We check the elements. You have 1, 2, 3, 4, 5. So we have 5 elements. So we just have the cardinality to just be 5. Okay. So question 9, we have A cross B. So A cross B has to do with the cross of the Cartesian products, or we say the cross products of two sets, right? And if we are finding the cross product of two sets, if it is A cross B, A should be representing the first element within the other pair, and B should represent the second element in the other pair. So now we have set A to be 2, 3, 5, and 7 up there, and set B is 7, 11, 13, 17, and 19. So we open our set like this, and then we have this set of other pairs. So we take the first element within set A, 2. So we pair 2 with all of the elements in set B. So we say 2 and 7. We say 2 and 11. We say 2 and 13. 2 and 17. 2 and 19. And all of the elements within set B. We now move to 3, right? So we say 3, 7, 3, 11, 3, 13, 3, 17, and then 3, 19. So you see we are pairing with each element within the set B. So A cross B. A must be the first element, B must be the second element. Now we are not using curly braces here because these are all other pairs. So we cannot use curly braces, these are other pairs. The curly braces includes these other pairs. So we move to the next element in set A, 5. So we say 5, 7, 5, 11, 5, 13, 5, 17, 5, 19. We've not done yet. We move to the last element in set A, 7, 7, 7, and 7, 11, 7, and 13, 7, 17, 7, 19. So all of these are the order pairs of set A and set B. So these are the cross products of A and B. So move to the next one. Get this one already. B symmetric difference C prime. So B symmetric difference C prime. Now we told you To find a symmetric difference, it's like saying B different from C prime union C prime different from B is our symmetric difference. So we say B different from C prime, and then C prime different from B. So there's our symmetric difference. So let's find the elements of our symmetric difference of B and C prime. So now B symmetric difference C prime now equals. So the first thing, let's find our B different from C prime. So B different from C prime. We look within the set B and within the set C prime. This is set B and this is set C prime. Now, B different from C prime means what are those elements that are within set B that are not within set C prime? That makes a difference. So we look in set B, we have 7. We got 7 here. 11, 11 here. 13, 13. 17, 17, 19, and 19. So there is no element that is different from B in C prime. So it is just an empty set. So the next one we find is C different from B. And that also becomes an empty set. So therefore, the union of these two sets, B symmetric difference C prime now, is just also an empty set. Right? So now move on. We have the next one, 11, question 11. A prime different from C. 11 says A prime different from C. And now, this is also written as A prime different from C. A prime minus C. So let's look at it. This is A prime, and this is our C. What are the elements within A prime that are not in C? 11, 11 is not here. 13, 13 is not here. 17, 17 is not here. 19, 19 is not here. So all of the elements within A prime are not in set C. So the difference are just all of the elements in A prime. So question 12. Question 12, we have the number of A cross C prime. The number of A cross C prime. Now, whenever you want to find the number of elements within a cross product, you just multiply. So this is just the number of A times the number of C prime. So what are the numbers of elements? What's the total number of elements in set A? In set A, we have 1, 2, 3, 4. So we have 4 elements. Times, what are the number of elements in set C prime? You have 1, 2, 3, 4, 5. So it's 5. So 4 times 5 is 20. So if you find the cross product for A and C prime, you can do it as an assignment. 2 and 7, 2 and 11, 2 and 13, 2 and 17, 2 and 19. You finish with 2. You come to 3, 3 and 7, 3 and 11, 3, 13, 3, 17, 3 and 19. You come to 5, 5 and 7, 5, 11, 5, 13, 5, 17, 5, 19 and 7, 7, 7, 11, 7, 13, 7, 17, 7, 19. You can list all of them. You'll find out that at the end of the day, there will be 20. So question number 13 now. We just have the number of elements within set A different from set C. So what are the total number of elements that are within set A different from set C. So let's first find A different from C. A different from C. This is set A, and this is set C. What are the elements within set A that are not in set C? A has 1, 2, 2, 3, 3, 5, 5, 7. 7 is not here. So 7 is that element that makes A to be different from set C. So therefore, the number now of A different from C is just equal to 1 element. So we have question 14. The number of B prime symmetric difference C. So again, we said the first thing you must do is to find your, because this is equal to, you must first find what is in here, B prime symmetric difference C. And this is B prime different from C union C prime different from B prime. So we first find our B prime different from C. This is B prime. What are the elements within B prime that are not in set C? The elements of B prime that are not in set C. This is set C, and this is set B prime. So we have all of the elements in set B prime, they are also in set C. So this is just an empty set. So we use the symbol law. What's about C different from B prime? What are the elements in set C that are not in set B prime? In set C, we have 2, 3, and 5. In set B prime, we also have 2, 3, and 5. So this is also an empty set. So finally, we want to find the number of, so okay, we just find this one now, right? Which is B prime symmetric difference C, which is this one. So it will just be an empty set. So if we want to find the number now of B prime symmetric difference C, this is an empty set. So you have 0 element. So we have the next question is okay, this is 13. This was 14. We're now on 15. So question number 15, we have the number of A cross B prime. So again, I said we want to find the number. We just distribute this and the number of A times the number of B prime. So what are the number of elements in set A? In set A, we have 1, 2, 3, 4. So it's 4. What are the elements in set B prime? Set B prime is 1, 2, 3. So it's 3. So 4 times 3 is 12. So next we have question 16, which is the last one now. The number of A union C cross B prime. So we do them in pieces. We first find A union C. So we say A union C is equal the combination of A and C. A and C. 2, 3, 5, 7. This is C. We also have 2, 3, 5. So they get ends right there. This is A union C cross B prime, right? So it's A now union C. Now we're asked to cross this with B prime to find a cross product. So this is A union C, which is that set, and then this is B prime. What is B prime? This is B prime 2, 3, and 5. So that we consider as one set, and this another set, right? So remember we told you if you are finding the cross product of 2 sets, it means that you must find, okay, since we're asked to find the number, we don't have to go further. We just say the number of A union C times the number of, just distribute them, right? The number of this times the number of this. So the number of B prime. If you whom alone you can do the cross product and see for yourself. So the number of A union C has how many elements? 1, 2, 3, 4. 4 elements. And the number of B prime has how many elements? 1, 2, 3. So you have 3 elements. So you have 4 times 3 is 12. So thanks for watching. See you next class.